Okay, so in this self-check, we've asked you to create two new gate classes, one called a NOR gate and one called a NAND gate. All right, so again, what's important to know here is that NAND gates work just like AND gates, except for that when an AND gate would return a 1, a NAND gate is going to return a 0. And a NOR gate works like an OR gate, except again, when an OR gate is going to return a 0, a NOR gate will return a 1, and vice versa. All right, so the key to solving this in a very quick and easy way is that we are going to make use of inheritance. And so let's take a look at the NAND gate. So the NAND gate will inherit from AND gate. Now, when we have an inherit from NAND gate, we want to ask ourselves the question, do we need to make up a new init method? And the answer to this is no, because we're still going to do the same type of initialization that we do in any other gate. We're going to set the pin value to none. All right, so we don't even have to write an init method in this. The only thing that we have to do is we have to change our perform gate logic. Now, we could write it similarly to how we've done it in the AND gate up here. We could get pin A, we could get pin B, we could check to see the values of pin A and pin B and figure out whether we should return 0 or 1, but we can do this even easier using inheritance. And so all we're going to do is we're going to call the perform gate logic method for the AND gate, and if it returns a 0, we'll return a 1, and if it returns a 1, we'll return a 0. So to do this, we need to arrange to call our parent class's perform gate logic method. Now, this is similar to what we've done here in the other gates. So with our NOT gate that inherited from unary gate, we simply called unary gate dot underscore underscore init n. Same thing that we did up here for the OR gate. We called binary gate dot init. All right, but we can do this in an even easier way in Python 3. It's a little bit less obvious what's going on, but it's a good thing to know nevertheless. So let's start out by defining our perform gate logic. And in order to call our parent class, we're going to make use of the super function. And what super does is it returns a proxy object that stands in for an instance of the parent class. So we can say super dot perform gate logic, and that will call the perform gate logic method in the parent. Now, we want to wrap this in an if. So if super perform gate logic returns a 1, we want to return a 0. Otherwise, return a 1. And so it's just that easy. We've now created a NAND gate. Now we can easily add our NOR gate using this same pattern. It'll inherit from OR gate. We'll define our perform gate logic method, and if the OR gate perform logic return to 1, then we'll return a 0. And that's all we have to do. Now we can go down here and do a little test of this. I've already got this set up. We'll create G2 as a NAND gate, and then we'll get the output from that. So if we run our function, it'll ask us to input a value for pin A. So let's do a 1 and a 1. Now clearly if this was an AND gate, the output would be 1. But notice that it's a 0. All right, let's try running it one more time. And now it's going to ask, let's try 0 and 0. And now it's going to return a 1. So it's clearly doing the opposite of what the NAND gate would have done. You can try the other two combinations of 1 and 0 and 0 and 1, and you should try now to type this in and modify it and try the same thing for the NOR gate.